Welcome Hugo Proença, Senior Machine Learning Scientist at Booking.com. Hugo will be exploring how converted data can be enough for most promotion uplift modeling in e-commerce. And as always, Slido is open for your questions. Great. Welcome, Hugo.
Oh, thank you very much. Just preparing the timer. But I have to tell you that this is going to be some maths. It's going to be simple, but there's going to be some maths involved. There's no LLMs, so I'm disappointing you right now. But so what I want to see, and I want to say a bold claim, is that converted data for most promotion cases and for even some pricing kind of experiments is enough in e-commerce. And I'll try to show you why. And there's another side topic for people that are more into causality, is how can you use a collider to actually get information out of the data. So the quantities of interest that I'm actually mentioning here is the relative uplift, so how much did it increase from your baseline? We go through it. Relative metrics like revenue and cost, and the return of investment, which is in the end what a lot of people are interested about. So I would talk a little bit about why this actually matters for e-commerce. So there's a lot of search data, and if you're in a big company, you have millions and billions of search data. So sometimes this data is not only large, it's full of things that you don't want and are just adding noise, like bots and crawlers, individuals without interest that they were just browsing around. The other thing is that using only the converted data, it's way more efficient in most cases because you use less data. And anyway, if you have so much data, usually you end up sampling at one point. So sampling what actually matters. And there's a lot of people that came up in research with zero-inflated models to model these kind of problems. And what I'm just saying is that you don't need it. You can just remove that data and still get actually very good results. I'm saying that the requirement you need A/B data. It's not exactly true. Actually, everything of these holds if you use propensities. But the only quantity you need from search or from user level is the propensities. So are these people in the treatment or in the control group? And I need to know. If it's a randomized trial, A/B test, it's 50-50. I already know that in advance. I don't even need to calculate it. If you have a model, you can train a model for learning that, and the rest you only need the converted. So just to give an example, imagine you are in a large e-commerce business and you have 1 million sales. I'm just giving a little bit of context. Actually, the maximum conversion in most e-commerce businesses is 10%. So you get to 10 million visitors. Then imagine they do 10 times their searches every time they're searching for something. We're already in a very big number, and this is per day. And this is companies like Amazon, Booking, Uber. All these companies have this actually bigger than these values. So that's why I'm saying you can just use the upper quantity, which is way nicer. If you're a small company, you are saying, what does this matter for me? And that's a good question. And a lot of small companies, actually, they don't have the user journey. They don't know what users have been doing along the page. So they actually only have transactions. And you can just use those transactions. This is the mandatory thing to actually save, to model everything about it. So first I have to do an intro to causal inference for if there's people here that don't know, but it's going to just be small and into potential outcomes. So first, what I want to say about individual treatment effects and what we want to measure. You measure here that we're calling about conversion, and why is conversion? You just want to know, 1, if they converted, 0, if they haven't converted, right? And the 1 means that they were treated. Maybe they saw this 15% discount for a car rental. And so why 1 represents what people would have reacted if they saw that. And this is if we know everything. We are an oracle. We know everything. So this is our ground truth. And then we want to know how they would have reacted if they have never seen the discount. And the difference between that is the individual treatment effect. We can calculate an average over that, and we would call it the average treatment effect because we know everything again. Sometimes people call it incrementality in e-commerce and in other areas. And you can add covariates, and if you add a covariate, let's just say 1, 0, You can also calculate the conditional average treatment effect. So for a specific subset of the population, how would they react to this discount, right? But there's the fundamental problem of causality, which is that we actually don't know. We don't know if someone saw the discount, we don't know how they would have reacted if they hadn't seen the discount, because they saw the discount. And so that's the biggest problem, and that's what we're trying to solve. I want to add another layer of complexity here, which is that when you are doing things related with money, with budgets, constraints, marketing, you add another layer. So you add revenue, you can add cost. So there's more potential outcomes that can come into account. And you have to take into account all of them to actually model this properly. So let's see a simple example. Bob, he hadn't converted when he hadn't seen the discount, but when he saw this discount, he loved it. He really wanted to rent that car. He rented the car. So Amy, in that case, still rented the car, but she decided to buy even something cheaper. So what we see is that Bob increased his conversion, so there was an uplift in conversion, and there was an uplift in revenue. For Amy, the conversion maintained and the revenue went down. And this is not people want to discriminate or anything like this. You are running a promotion, you want it to be efficient, or you want to know the markets or the segments where your promotions actually work best to actually plan them in advance. So I go to this specific case, which is a niche case, but is actually most common in e-commerce, which is triggered revenue or triggered costs. So if you don't convert, there's no costs, there's no revenue. So no one is going to pay for a discount of something they never bought. So there's no cost there. So that's what it means when the conversion is zero, there's always zero cost, zero revenue. So you only have it when it's converted. And that's why you can do all these tricks that I'm going to show. So imagine you have this randomized data, 50-50%. Some people converted, others didn't convert, right? So we have the control group, 2 people converted, 2 didn't. Treatment, 3 converted, 1 didn't convert. We have this non-converted. I'm going to remove them, and I'm going to show you that you can do most of the things without them. So the first thing you can do is you can just calculate something called incremental conversions, let's say. And here you have 3 minus 2. So the control group just represents the world, what would happen in that world if I hadn't done anything, right? And the treatment group represents if I had run that discount. So, I don't know what happened there. But the lift is, I would say, an interesting metric that is hard to understand from this formula. But we go through that. You get the number of the ones in treatment minus the control, and you divide by the control. So 3 minus 2, 2, 0.5, 50% increase. So this is the lift. It's a lift of 50%. I will say why lift is more interesting than incremental conversions in most cases. I mean, let's look at this simple case. You have incremental conversions are the same in both cases. And you'd say, maybe the case 1 is more interesting. Yes, it is more interesting. You grew your business more. So from where you started to where you grew, your business is way better there. So you had a bigger lift. You had a bigger incremental increase. And lift shows you that. I put a formula here, and now you're going to get lost. And that's all right, because I'm going to explain it. But so this is a weird concept to grasp your head around. So it's the probability of being treated given that you have converted, right? So this is weird. You can do it with just one classifier, one model of this, and I'll show you. And this just means the ratio of converted per treatment. So 3 divided by 5, right? So there's 3 people in the treatment, there's 5 in total, so you get this 3 divided by 5. What does this mean from a causal graph perspective? So I want this quantity, the probability of being treated, given that I converted. So this is looking back into the past. So this looks a lot like a propensity, but it's not a propensity. Because we already know the propensity, we run an A/B test, and there's 50-50 chance of people getting the discount or not. So what does this mean? So we have randomized data. We break the relationship between the covariates and the treatments. And then we grab this collider, and we create a relationship with them. We create a dependence given the converted. So what is this going to show us is we have the propensity, it's 50-50%, and I'm asking the question, How different is this from 50-50? Which is going to mean that there's more people that actually converted in the treatment than in the control. And through that, you can get a relationship. So this just means 3 divided by 5. So this is a nice quantity. And I'll just call it the ratio of converted to make it easier for us to talk about it later. But how do you train this with a classifier? You just join all the converted only data set. You join it all together. You say the control is 0, the treatment is 1. You run a classifier on that, and you predict it. That's it. So, I mean, I had to take a cheesy take on it, right? I think it's nicer to have the lift. You also can have the average things. I just showed you. You can calculate incremental conversions directly from the only converted data. But I would say the lift is more interesting for most cases of business questions you are answering. But then people are saying, okay, but we need to take into account revenue, cost, and all these things. And let's go into that. So I added some random numbers. This doesn't represent any business decisions, just to make sure. But so there's these random numbers here. And you can calculate incremental revenue from this because you know that all the non-converters are 0. So you can just calculate them. And you get these 5, let's say euros or pounds if you prefer. But you get these 5 euros. And you can calculate this weird quantity that I will explain a little bit, but it's hard to grasp your head around it too. Let's call it incremental revenue per conversion. You have 5 conversions in total, and you have 5 euros. So you get 1 euro per incremental conversion. No, not per incremental conversion. 1 euro per conversion, let's say. And I'll show you again that this is way more interesting for most cases. So you have the incremental revenue. Everyone gets 10 euros. It doesn't matter. Don't ask questions. It's 10 euros for everyone. You have the same incremental revenue. I calculate the incremental revenue per conversion, and I see that the first case is better. Yes, we grew our business more. You can calculate it just from converted data. And you ask me, how can I calculate this? And again, you can calculate it very easy with a regressor. You just grab only the converted only data. You grab the control, you make it negative. You grab the treatment, you make it positive. And you can calculate this directly. You should add some propensity scoring here. I just didn't want to add that slide. It's in the end. But you get this. You can also find it in segments. So everything I'm saying, I'm talking about the averages to make it simpler to explain. But when you train a model on this, you are also learning it on the segments, right? You are learning these lifts per segment, this incremental revenue per segment. So you can also calculate things like cost, incremental cost per conversion. And incremental profit, it's not really profit, it's net revenue, but it makes it easier to talk about it. So let's say I added the incremental profits, and you can add it, and they all sum up. We run some experiments. This was a very hard data set, that's why all the models are kind of terrible. But the main thing that I wanted to show is that even we're trying to solve another problem, it was just incremental net revenue, incremental profit in this case. But just the model was quite stable, worked very well, was comparable with all the meta learners we had actually tried. And of course it trained in 100 times less time because there was just 3% of conversions. And that's what I'm mostly trying to say. The performance is more or less the same, and you just remove all the data. This was on synthetic data, but if you do it on real data sets, sometimes it can be better because the search data contains other things that you actually just would like to have removed. So the takeaway, this is cool, but doesn't mean something we actually know very well. So it relates very well with this incremental revenue concept, but it's not exactly that. But we'll go into it. But you'd like, okay, I don't really care about revenue. I care about my return of investment. So tell me about return of investment. And everyone loves it. So I added an extra column, costs. So you grab the revenue in the treatment, you grab the revenue in the control, you divide it by the costs. I'm assuming there's no cost in the control. Maybe you have costs in your control, I don't know. But most of the times there aren't. So you just grab these things, you sum them up, and you obtain a value. So you can call it incremental revenue, incremental cost, and you get this beautiful 1.4. So for every euro you spend in your marketing budget, you get 1.54 euros back from revenue, which is great. We want to run through. This is a great business. Now I'm just going to tell you how you can calculate it. It's a little bit more involved, but not too hard. So we get back to that quantity of the ratio of converted per treatment. And the other quantities are just the expected revenue per conversion. I'll walk you through it to make it more simple. So the average revenue in the control group is 15 euros. The average revenue in the treatment group is 12. If you just look at these averages, you would probably say that you would make this business because it's a bad business. But the thing is, what we want to say is that this 1.4 is that this extra conversion, actually this extra purchase, actually compensated for this loss in average revenue. So it still made sense to make it as a business decision. And you would get, again, the 1.4 with this calculation, if you go through. There's another way to calculate it, is that weird z-transform I said. You just use the converted only, you make it negative, you make it positive. You get these two values. You look at them with your eyes, you pierce your eyes. You cut those two things, and you get 1.4 again. So all of these things just say that because you have 0 on the non-converted, you can make most of the business decisions only on the converted only. And this simplifies a lot in big companies, in companies that have very small ratios of conversion. I mean, I made it here a Gini curve with synthetic data again, so not business critical information. And I mean, this was just a simple thing to demonstrate that if you make these decisions on, let's say, an incremental reward, revenue, incremental cost kind of terms, they are literally equivalent. You get the same models, you get the same decisions, just on converted only data with way less data. And that's actually the main idea of what I wanted to say here. And so my conclusions are, you can do it directly on converted data. It's way faster and more efficient. It sidesteps a lot of times large and noisy data sets, and it performs on par with state-of-the-art methods. So that's it.
To use only converted data, do you need a 50-50 split?
No.
John, explain.
Oh, yeah, sorry. You don't need, I mean, you just use it as a propensity. You can use whatever value you want. So if it's, if you get 90-10 or if you get 80-20, you just divide, you just scale them proportional, right? So you have 20%, you scale them by 1 divided by 0.2. That's just it.
And have you used any specific frameworks for the workshops you ran? And any learning to get buy-in and engagement for these?
For the frameworks, I mean, to be honest, a lot of people are very curious because we say we're from Booking. So for the workshops we run, a lot of people get very curious because we say we're from Booking. So a lot of people come. But also it's because it's a nice topic and it's a topic that a lot of companies are dealing with. And people want to know what are the other industry experts doing. So I would say that's how a lot of people come. Yeah. It's a topic that moves some money.
And you got away lightly. There's only one question left, which was, how did causaLens help you achieve this? But you're not working with us.
No, so I haven't worked with causaLens. Long ago, actually, I have talked with people from causaLens. I've worked in some companies with people from causaLens that were not there anymore. So, I mean, I always have looked at causaLens for a long time, actually, because it's one of the only causal dedicated companies that have been here for a long time. And it actually has been very inspiring to see what they have built over the years, to be honest. Yeah.
We'll quote you on that, you know that. Sorry, no, see, questions now pouring in. We've got a couple of minutes, haven't we?
It was a great presentation, so no one has.
Yeah, they're all asking us anonymous. How do you account for fundamental differences in baseline conversions between test groups? Make sense?
Can you repeat?
How do you account for fundamental differences in the baseline conversions between test groups?
I mean, I think this probably relates with the last talk we saw of how sometimes the control group is different. So, I mean, hopefully you can run an experiment where they are fundamentally the same. If you can't, this becomes way harder, right? So you cannot randomize on that. We try not to ask that kind of question directly because then you can have biased business decisions, and especially biased business decisions involving money can lead to bad outcomes. So we try to avoid it by possibly experimenting.
So I should start this question by saying I head up the marketing team in causaLens, but this question says, any challenges convincing marketing departments to use this, since it can challenge their current methods by showing results are bad? It's not a thing in marketing. I don't know who asked that. So basically, how do you get buy-in of marketing?
I would say that marketing departments are very interested in finding new ways of how to actually leverage their capacity, and especially at scale. And they have, from my opinion, very early on have adapted causal perspective into it because it's just essential. You are creating an intervention in the market. So you are fundamentally changing what's happening. So just predicting is give you biased results that don't lead to good answers. I mean, I think it's very clear. You run an experiment with with prediction-only models, and a lot of times it just doesn't fit.
And the last question, promise, is how do you perform targeting with this model, considering that you did not use non-converted user data to train it?
Oh. So the key question here is that so a lot of times when I show this to people, people think if I use non-converted data, people think that I'm losing something, and I'm losing some information, of course. But what I'm mostly saying is that by comparing the control and the treatment just on the converted, you get the difference in which segments, which subgroups actually behave differently. And that's how you answer. I don't think I completely answered this question, but we can talk later.
I was going to say, he'll be around rest of the day?
Yeah.
Yes, and at the breaks. So grab Hugo. Otherwise, I'll let him go. Thank you.
Thank you very much.